Hello, so I don't know what happened to Big Blue Button today, so I'm gonna record this lecture for you guys and then hopefully post it with no problem. Okay, so today we're gonna talk about logarithmic properties. So let's go over some of the properties of logs. Okay, so number one, some properties of logs. Okay, so this is log base b of b is equal to 1. Log base b of 1 is equal to 0. Log base b of b to the x is equal to x. So these are some properties that we're going to keep referring to and going back and forth to. So you might want to just keep them handy somewhere. Log base b of m to the r is equal to r times log base b of m. Just gonna look at something really quick. Okay, and then log base b of m times n, we can break it up into log base b of m plus log base b of n, and then log base b of m divided by n can be broken up into that. Okay, and we've kind of talked about the graphs, right? So now we're going to just use these properties to simplify some of these logs. So notice this is log base 3 of the 9th root of 3. So we can actually rewrite this as log base 3 of 3 to the power of 1/9. Okay? So now notice that this looks very similar to property number 3. Okay? Let's go back to property number 3. Right? So you notice log base b of b to the x is equal to x. So log base 3 of 3 to the 9th is going to equal to 1/9. Okay? So it's using those properties to simplify. 8 to the power of log base 8 of 44. This is very similar to property number 4, right? 8 to the power of log base 8 of 44 is going to equal to 44. Log base 2 of log base 1/2 of 1/4. Okay? So let's rewrite this log base 2, right? And then we can put the brackets log base, this is the base 1/2. So I'm going to rewrite 1/4 as 1/2 squared. So now I get log base 2, log base 1/2 of 1/2 squared is equal to 2. This becomes 2 in here using the same property as the first example, right? And then this log base 2 of 2 is going to just equal to 1, right? Log base 2, that's property number 1, right? Log base 2 of 2. Find the values, right? So log base 10 of 10 to the 7th. Okay, so this is equal to log base, remember log without anything is the same thing as saying log base 10, right? Of 10 to the 7th. So when you don't see a base, it means, when you just see log, it means base 10, okay? So this is going to equal to 7. This is going to be equal to 3, right? Property number 3. Log base 9 of 9 to the 0.25. Same property, right? 0.25. Property number 3 again. Log base 2 of 2 to the power of 4x. Same property is going to equal to 4x. So properties of natural logs. Natural log of e is equal to 1. Remember, natural log, this just means log base e. So instead of saying log base e, you're going to see natural log. So these are the properties. Natural log of e is 1, natural log of 1 is 0, natural log of e to the x is x, e to the power of natural log of x is going to equal to x. Okay, find the values. Natural log of e to the 5th. Remember that is the same thing. You can look at it, right? Natural log of e to the 5th, right, is going to equal to 5, right? Based on property number, or the third one, right? E to the natural log of 6 is going to equal to 6. Just based on the properties above, right? That's the fourth one. Natural log of e to the negative 3 is going to equal to negative 3. Natural log of e to the 3.5 is going to equal to 3.5. Natural log of e to the power of x plus 3 is going to equal to x plus 3. Okay, so let's find the values. Here, so it's natural log of 1 over e. Well, we can rewrite this as natural log of e to the negative 1, which is going to equal to negative 1. We can rewrite this as natural log of e to the 1/2, which is going to equal to 1/2. We can write this as natural log of e to the negative 1/2. So therefore, this is going to equal to negative 1/2. Okay, so e to the natural log of 4 is going to equal to 4. E to the natural log of 92 is equal to 92. E to the natural log of the quantity x minus 7 is going to equal to x minus 7. So find the exact value using logarithm properties. Okay, find the exact value using logarithm properties. So we have 5 to the power of log base 5 of 6 plus log base 5 of 7. So we're going to use the properties here on the very first slide, right? So if we have, right, so if we have log base 5 of 6 plus log base 5 of 7, we can actually use property number 6 to combine them, okay? So I'm using property number 6. It's going to be, I'm going to rewrite this as, let's see. So I'm going to rewrite that as, so 5 to the power of log base 5 of 6 plus log base 5 of 7. That's going to be 5 to the power of log base 5 of 6 times 7. That's property number 6, okay? So now we can rewrite this as 5 to the power of log base 5 of 42. Right? So when it's written like this will equal to 42. Because we have property number 4 now. So if it's 5 to the power of log base 5 of 42, that's going to equal to 42. That's property number 3. Okay? So we use two properties there. Express log base 9 of x squared times the quantity square root of 3x minus 5 as a sum or difference of logarithms. Express powers as factors. So we can, again, it's being multiplied, so you can look at it as log base 9 of x squared times that, right? So we have a product. So it wants us to write it as a sum or difference. But we know if we use property number 6, we can write it as a sum. So this is going to be log base 9 of x squared, right? Plus log base 9 of the square root of 3x minus 5. So first we used property number 6 to break it as a sum, okay? Now it also says to express powers as factors. So what we're going to do is we can use property number 5. So whenever we have an exponent, we can use property number 5 to express it as a factor, okay? So this one can be expressed as 2 log base 9 of x. Again, this is property number 5. So plus log base 9 of, remember this is, we can rewrite this as 3x minus 5 to the 1/2. So now we can express the second term, right, as 1/2 times log base 9 of 3x minus 5. And now we've used property number 5 and number 6 to write it as sum or difference, and we express the powers as factors, okay? So these were the powers that we expressed as factors, right? So this power got expressed as a factor, and then this power got expressed as this factor. Express natural log of x plus 5 to the power of 4 divided by x cubed. So as a sum or difference. So now there's division here, so we're going to use property number 7 here, okay? So we're going to use property number 7 to write it as a difference. Okay, so it's going to be natural log of x plus 5 to the 4th minus natural log of x cubed. So that's property number 7. Now we're going to use property number 5 to write the powers as factors. So it's going to be 5 natural log of x plus 5 minus 3 natural log of x. Okay, so now we're going to express as a single logarithm without negative exponents. Okay, so now we're going to go, so all those properties, make sure you can go in either direction. Now notice that in this particular example, we have 1/2 as a factor here. So it says and we have 2 terms because they're being added. So now we want to express this as a single term. So we begin by moving the factors into the exponent position. So we're going to rewrite this as log base 6 of x to the 1/2. And then plus log base 6 of x minus 2 quantity squared. So now we just moved the factors into the exponent position. These are the factors that I just moved into the exponent position. Now that I have that, I can rewrite this first term as log base 6 of the square root of x, and then plus log base 6 of x minus 2 quantity squared. Okay? So now I move the factors into the power position and went from exponential to radical form in the second step. And now I'm going to turn it into a single logarithm by using property number 6. So now this is going to become log base 6 of the square root of x times x minus 2 quantity squared. Expressed as a single logarithm without negative exponents. Okay, so there's subtraction involved here, so I know that I can use property number 7 to write it as a division problem. So this is going to be natural log of x squared minus 1 divided by x plus 1 quantity squared. Okay, so I have it written like that, but notice that I can rewrite the top as x plus 1 times x minus 1 because that's a difference of squares, and then the bottom I can write it as x plus 1 times x plus 1. Now notice that these two, right, will become 1. So this becomes natural log of x minus 1 divided by x plus 1. And that will be my final answer. So change of base formula, you can go from any base, so you can go to a log base 8 to a log base 10. You can go from a log base 5 to a log base 3. You can go from any base to any base that you choose, okay? So the idea behind the change of base formula is if we want to use our calculator, right? Remember, your calculator only has log base 10 and log base e, which is natural log. It doesn't have a button for any other base. So if you wanted to compute anything using your calculator, so say you wanted to compute a log base 8 problem, well, you're going to change log base 8 to log base 10, and then you can use your calculator. Or you want to change log base 3 into a natural log, and then you can use your calculator. So that's the idea behind this, okay? So use the change of base formula to calculate log base 5 of 8 to 2 decimal places, right? So we want to calculate log base 5 of 8. So what is log base 5 of 8? Right, so log base 5 of 8. I mean, we can't use our calculator, right? So that's why we have to change the base formula, so we can't compute that. So if we change it to a log base 10, so say we want to change log base 5 of 8, we're going to do log of 8, because that's what it says to do, right? So a is 5 here, m is 8 here. So we're going to do log of 8, because this is log base 10, divided by log of 5. Notice, log of 8, I can use my calculator, divided by log of 5, I can use my calculator, and then I'll get a value, okay? Because log, I have that button on my calculator, and that's going to be about 1.29. Okay, and that will be my answer. Okay, because again, remember log is log base 10. So you can also do natural log of 8 over natural log of 5. This will also give you the same exact answer. So you have a choice. You could change it to a log, which is base 10, or you can do it natural log, which is base e. They both give you the same answer. Okay, so the next problem, log base 3 of 8 times log base 8 of 9. Again, we can't use our calculator, so we have to change the bases. So we're going to change log base 3 of 8 to like a log base 10, right? So this is going to be log of 8 divided by log of 3. So that's the first one, times log of 9 divided by log of 8. So notice that you can actually divide those out and you get 1. So this will be log of 9 over log of 3. And this, using your calculator, is going to be some value that I did not calculate. Let's see. So log of 9 divided by, log of 9 divided by log of 3. And that's equal to 2.